Good morning. So we're going to start. Yesterday we looked at oxidation and reduction, and we're going to continue with looking at oxidation and reduction. So we realized that we could define oxidation in terms of four different categories. Oxidation involves the increase in oxygen, increases oxidation number, decrease in electron, and decrease in the number of hydrogen. Of course, reduction is going to be the opposite. Reduction involves a loss of oxygen, loss in oxidation number, an increase in electrons, an increase in hydrogen. And we also looked at the acronym LEOGR, which signifies loss of electron for oxidation, gain of electron for reduction. And the other acronym, ORIG, oxidation is lost and reduction is gain. So these are normally the most common ways in which oxidation and reduction is defined. It's defined mainly in terms of electrons and oxidation number. So for the remaining few sessions, we're going to look at oxidation and reduction in terms of oxidation number and electrons. So today we'll be focusing mainly on that portion. So in a reaction where we have oxidation and reduction taking place, those reactions are called redox reaction. Of course, the name comes from read part comes from the reduction and ox from oxidation. The combination gives us that redox reaction. So let's try to keep track of our electrons. Here we have sodium forming a sodium plus charge and electron. If we were to look back at our sodium atom, a sodium atom could be found in group 1, so it's going to have one electron. If this electron is lost, we're going to be left with the sodium with 1 plus charge. So here we have sodium losing this extra electron, this valence electron, to form a sodium plus and one electron. This is plus 1. So here oxidation number is plus 1. Originally oxidation number was 0. So any element in its natural state would have an oxidation number of 0. So we're moving from a 0 to a plus 1. From 0 to a plus 1, so we have an increase in oxidation number. So this is an example of an oxidation. We can think about it in two ways. There's an increase in oxidation number and there's a loss of electron. Let's go back to our definition. Oxidation, increase in oxidation number and the loss of electron. So we can see that example, an example of oxidation. So let's look at the second example. Here we have zinc. Zinc can have a valency of 2 electrons and there is oxidation number of 0. Remember, it has oxidation number of 0 because if we were to look at the amount, like let's look at this sodium. This sodium originally had 11 electrons. It also had 11 protons. When it lost an electron here, we're going to have 10 electrons and still 11 protons because we're not going to change anything inside the nucleus. Only thing we are doing, we're removing this electron. So here we will end up with a 1 plus charge here. Similar situation with zinc. We have 2 electrons in the valence shell. We have the same number of electrons and protons. We're going to lose these 2 electrons, so we're going to end up with a 2 plus charge. And again, this is an example of an increase in oxidation number, so we know it's oxidation. And then also we are losing electron, so again this is oxidation. The same thing here for magnesium. Magnesium is losing 2 electrons. This is oxidation. So let's look at this. Chlorine gained an electron. So chlorine originally had 17 electrons, 17 protons. This chlorine gained an electron. Now we're going to have 18 electrons and 17 protons. So we have an overall charge of -1. So here we're going from 0 to -1. There's a reduction in the number, in the oxidation number. From 0 to -1 is a reduction in oxidation number. So this is an example of a reduction reaction. Reduction, decrease in oxidation number, and the gain of electrons. Here, this chlorine atom is gaining an electron and reducing the oxidation number. So this is reduction. This is also another example of reduction. We're moving from a 0 to a -2, 2 minus. This is a reduction reaction. We gain electrons, oxidation number also went down. Okay, so we're going to look at half equations. What do we mean by half equation? So we're going to first look at a reduction half equation. A reduction half reaction shows an atom or an ion gaining one or more electrons while its oxidation number decreases. Remember we said that reduction involves an increase in electron and a decrease in oxidation number. So here we have 4 examples. We're going to try to determine which one of these represents which half reaction correctly represents reduction. So we're looking for something where there's a reduction in oxidation number. We have a 2 plus, we're going to a 0. So this is a reduction. We have a 2 plus to a 3 plus. This is an increase. We have a 0 to a 3. That's an increase. We have a 0 to a 3. This is an increase. So the one that represents a reduction would be A. Okay, let's look at another example. Consider the following redox reaction. Ni, that's nickel, and tin with a 4 plus charge, going to nickel with a 2 plus and tin with a 2 plus. Which species has been reduced? So we're going to look at these in trying to identify which has been reduced. We have to look at the reactant side. So we started with a 0 and we end up with a 2 plus. So this is oxidation because we have an increase in oxidation number. We start with a 4 plus and we go ending up with a 2 plus. This is a reduction. So which species has been reduced? We found out that this is been reduced. So this would have been the correct answer. So we're going to now look at an oxidation half reaction. An oxidation half reaction shows an atom or an ion losing one or more electrons while its oxidation number increases. So oxidation reaction results in an increase in oxidation number and we're losing electrons. So here we consider the following equation. Iron with a 3 plus reacts with tin with a 2 plus to give iron 2 plus and tin 4 plus. So we're going from 3 to 2. This is a decrease in oxidation number, so this is being reduced. We're moving from a 2 plus to a 4 plus, So this is undergoing oxidation. This is being oxidized. So which species has been oxidized? SN2 plus. Okay, so we're gonna do some practice on our worksheet. Thank you.